Today, we're going to be proving the converse of the Pythagorean theorem. So the Pythagorean theorem states that a squared plus b squared equals c squared. The converse of the Pythagorean theorem states that if the longest side, or the hypotenuse of a triangle squared, is equal to the squares of both of the other sides, then that triangle is a right triangle. So we have to prove that this triangle here is a right triangle using the Pythagorean theorem. So our first step is constructing triangle DEF right here. In this triangle, DE will be congruent to segment AB, or D is congruent to A. And also DF will be congruent to segment AC in this construction. So now that we have that, we can do this in substitution here, where side EF equals ED squared, where the square of EF equals ED squared plus DF squared. And that's using the Pythagorean theorem. So which also equals a squared plus b squared. On this triangle here, BC squared, the hypotenuse, is equal to AB squared plus AC squared, or a squared plus b squared. Now, using the transitive property, we can find that both of these equal a squared plus b squared. So therefore, EF squared equals BC squared. And if we simplify that by dividing both sides, one side by EF and the other side by BC, we can find that EF equals BC, or in this case, side F equals side C. So now we have that both hypotenuses are congruent to each other, as well as both legs of the triangle. Therefore, by the side-side-side postulate, we have three equal sides on these triangles, which means these two triangles here are congruent. And in that case, by using the corresponding angles of similar triangles, we can find that angle D here, which is a right angle, is equal to angle A. And this is because they're similar triangles, so therefore all their angles are congruent. So in this case, ABC has a right angle, A, which is 90 degrees, equal to the measure of D. So therefore, by the definition of a right triangle, ABC is a right triangle.